on my way down, I made a few calls. Unfortunately, fortunately, there was some funding available through the state here about a year and a half ago. That's essentially dried up pretty much. You're talking about $500 to $1,000 per kW for the PV system. And then if you want to store that energy and use it off-peak, again, you're looking at a battery system. Believe it or not, Vermont, even though a lot of people are looking at photovoltaics, and I've got one project right now at the Burlington Airport where we're doing a 400 and something kW worth of electricity, which is a lot. That's a $2 million, that comes with a $2 million price tag. So you can see that you got to spend a lot of money to get a little bit of a return. The payback on that, and the airport's willing to do it, is between 7 and 8 years. We also looked at a photovoltaic system for, and I'm going to get into that a little bit in a little bit more detail, for a dorm project that we did at Norwich that was kind of an afterthought. Structure's already designed, brand new building. And by the time you got the requirements for how big these panels were, the weight of the panels, the amount of wind that's placed on the panels, and you bring that back to structure, the cost was, the university said, no, we're not going to do that. They ended up putting in a small system of hot water, which made a lot more sense to them. They were looking at a 3 to 4 year payback. They were not looking at 7, 8, 9 year payback. So that's a real balance. You've got an existing building here. When you add numbers of photovoltaics on a roof, you have to have a very detailed structural evaluation done. Quite often, the infrastructure has to be beefed up in order to support the ballast for these big PV panels. You know, the panels end up being as big as one of these larger bookcases, and you know, they end up ballasting these so they don't end up being a sail and blowing off the roof. And currently, if the Fed continues to, and the state continues to have a high interest and wants to continue in putting money into photovoltaics and other alternate energy sources, I say that's something that could be looked at as we go down the road. But you know, there are other stored energy mechanisms like flywheel technology and a few other things. It's certainly not applicable to a school your size. I would put most of your money and your thought process into energy efficient systems, lighting systems, control systems, and insulation. Insulation is huge. If you can do windows and the rest of it, that's really where the payback is.
We have a lot of existing walls here that are going to be very difficult to add insulation to. But
right, but I mean, if you know where I'm coming from, John.
I do. I would agree with you that, you know, it seems like a big building, and yet we're working very hard to get that electric bill down through the lighting and the variable frequency drives on the mechanical system motors. You know, plus there's times of the year that you don't even use very much here.
Right.
If you had in a fully air-conditioned building, that would be a much bigger air conditioning load. On the other hand, I do have the PV discussion later on the agenda because I think there are some interesting options there that we should talk about, because you are a school and there are things that you can learn from that, and there are you can be leaders in kind of furthering that discussion, especially with, I mean, middle school students are sponges, and
yes,
they pick up on that stuff, probably even more so when you're not telling them directly. So I think that there are some possibilities that we can look at there, and that maybe there's some test size systems that you can put in that aren't overly weighty.
Yes, exactly.
But the idea of trying to provide something that's going to provide all electricity that you need here it may not be a great idea. Another possibility for those things is hot water generation, and those typically have a shorter payback.
Right.
Except for the fact that you guys use almost no hot water here.
So,
you know, the dorm building at a university uses lots of hot water because
right,
those 20-year-olds take long, hot showers.
And several a day.
Right. But middle school students don't, not at school. You know, the kitchen is going to be your biggest use, and if we're good at this, we'll get you off of electric on that anyways.
Right.
So anyway, any other questions? Because I think looking at the agenda that we can let Bob go home and have dinner at home tonight.
My wife will be pleased. Thank you.
Any other quick questions there?
Yeah.
So we are going to be talking a little bit more about PV later on.
If we can get through
right?
this agenda. If not, it'll be early on in the next one.
Okay. Thank you. And if anybody has any questions, just get those to John, and I'll get an answer for you. And I appreciate you listening to me do my presentation. And everybody, thank you.
Thank you. Thank you.
Yes, I do.
The next thing on my agenda here is the asbestos assessment update. I realized since our last meeting that, yes, there is a report on file. It's pretty old. It was the mandated report from, we'll be generous and just say only 20 years ago. It has proven to be over the years not entirely comprehensive. And so when you do look at a project like this in a building, it is really recommended that you have a more thorough battery of tests done and a much better survey. And that survey was commissioned. AIM Group with Chris Crothers was hired to come in here. He's taken at least 75 samples, I'm guessing, or more. And has gotten most of those results back. He said there's a couple things he needs to come back right now and check on a couple of results that were, he called them anomalies. He just wants to make sure that there's not something that's all the way through the building. He did find out enough that he's given me a good budget to include in the cost estimate later, which is good that it's in there. You'll see that it's a relatively large number. It's a couple $100,000. There's a fair amount of pipe insulation still throughout the building. I think Rick, he found a couple spots that he sent you memos on to say, let's take care of those right away. And I'm guessing that that's underway already.
Well, yeah, we have a contract that did the original re-inspection sheet,
right.
So he's come back for repairs and he'll take care of those areas.
Exactly. So I think it's good. I don't think there were any real surprises yet that I know of, and unless one of these anomalies kind of mushrooms out of control, I don't think that's going to be the case. It looks pretty good. It's just that this is 80,000 square feet of building, and there's a fair amount of it, and and we factored that into both the phasing plans and the estimate that we've got here. So I just wanted to let the committee know here that survey's been done, and it's accounted for in the information I'm presenting tonight. The next thing I want to do is, as we talked about last time, pass those around, and I'm not sure how those got divided out. I'm not sure we have enough at this point, but it's close. The goal tonight was to come with a detailed estimate, and I said, well, there's a lot of work to do that. We really need to define the scope of work. And what we agreed was that I would go ahead, based on all the conversations we've had, make some assumptions, write them down, and base the estimate on that. And therefore, if you want to do more than I've assumed, we'll know that it increases the estimate. If you want to have a smaller estimate, we need to kind of reduce the scope of work. This is a work in progress, obviously still, and we need to start with what's the price and what are you buying. And you can decide whether you want to buy less, to spend less, or buy more and have it cost more. What I'm sending around right now is what I call an outline specification. When you do a construction project, we do specifications, and anything that's in the building. Oh, you need me to talk into that? All right. I'm trying not to get irradiated by the screen here. So anyway, anything in a construction project can be divided into one of 16 sections. And that's basically how I divided this up, just to make sure I hit everything that needs to be in here. This is the document I gave to the cost estimator so that he knew more or less what we were doing. Obviously, it's very preliminary because of, we can only go into so much depth at this phase of the project, but I think it's pretty good. I would, rather than kind of go through this thing line by line with you tonight, I want to present it to you, hit a few high spots. The good news is that it's documented, what's in this estimate and what isn't. And so if you have a question, you can read this. I would urge you to read this. This will be very handy to you as you do some deliberations on trying to determine a final scope for this project. You can see that I've put a few allowances into this piece, which I've got listed under Division 1 General. You'll see here in a minute that I had a, or maybe I can pass that out here now. Seems to make some sense. The other person I had come by and look at the school building was a mason who specializes in old masonry. To take a good studied look at what you've got on the outside of the building to see whether there are any real problems that he could see. You'll see in this report, if you want to read it, that the brick is in pretty good shape. All the lintels on that old building above the windows and the sills are made to look like limestone. It's really just cast concrete. And since 1925 or whatever we've got here to now is a good number of years. And that is, those are pieces that are starting to deteriorate some. And so we've got some money in here to replace a good number of those things. There's an allowance, and you can see I said $150,000 for that. Brick cleaning, obviously not mandatory. I've included that in here now. If you're going to go through all this work, we felt that it was the right time to do that while you had the right people on site to do it. You can choose, obviously, some of these things to pull them back out if you want. I included $30,000. Interior corridor improvements, I felt that you've got some nice big wide corridors in this building, and that while this is a fairly straightforward proposal, that to generate some pride and to create, I think, an architectural atmosphere, or I should say an environment that the kids are going to enjoy being in and people are going to be proud of, I put a small allowance in here of $75,000, just essentially to kind of do something a little bit above absolute baseline in the corridors. I feel that that's a good spot to put a little extra color, maybe a little bit better, more durable material, a couple of lights to accent a few spots in those corridors. You've got a lot of corridors here. You've essentially got a donut on 4 floors, which is then, that's down to less than $20,000 a floor. Not a huge amount, obviously something you can take in, increase or delete. But I just want to let you know that that's in there. And I can't even tell you exactly what it is. It's just to include some money in there so that when we get into the finer points of this design, there's at least a budget there so that we're not just designing something that there's no money for and we can't afford. You can see here that we also said electric utility charges, $35,000. That's the money for GMP to come in and move that transformer off the poles and onto a pad, because they need to do that. The electrician won't do that. When you go through this, you'll see site work is actually quite limited here. We've got not very much concrete either. There's the new walk out front and the ramps. There's a new concrete retaining wall out back where we're going to build some new stairs out of the boiler room because the code requires 2 ways out. We'd like to upgrade those old stairs that aren't very good right now. And when you take out the old coal bin that's deteriorating rapidly, we just put in a new retaining wall there and a set of stairs. Otherwise, we're underpinning a little bit where we're creating those rooms by the front entrance. That's it. Not much. Not much on the exterior wall either, and insulation, simply because you've got good insulation up on the roof, underneath that roof membrane that we're not going to touch. I have suggested putting in a 4-foot sheet of foundation insulation kind of below that exterior insulation that's on the new part of the building that covers up that 6 or 8 inches. It's exposed to the weather and totally uninsulated, and goes down another 3.5 feet, so that you can, because that's where the frost is coming in. That's the coldest part of the ground. Once you get 4 or 5 feet down, the temperature differential between what the ground is and inside is actually relatively small, and the heat loss goes